Hi, Physical Science. Today we're going to talk about heat and thermal energy, which is chapter 16 in your textbook. Remember, you should be taking Cornell notes as you're taking these notes, so make sure you add your title, which is heat and thermal energy, and as we go to new slides, if the title changes, make sure that you change the header, and for every header you have, make sure you have at least one good question related to those notes. Okay, so first topic is thermal energy. And thermal energy is just the total energy, which is kinetic plus potential. So if it's moving, that has kinetic energy. If it's standing still or sitting still, it has potential energy. But something can have both a mixture of kinetic and potential. If it's not moving as fast as it can, then it still has some potential. So thermal energy is just all of that energy that makes up a substance. So we know that all matter is made up of atoms. And so the idea is that as you heat up things or as things get warmer, their kinetic energy increases. So that means that their thermal energy also increases. So if you think about atoms in a solid, liquid, and gas, as you heat up that solid, we talked about those molecules vibrating and eventually breaking free from each other and moving around, and that becomes a liquid. So as you go from solid to liquid, liquid to gas, you are making those atoms move more, and so they have more kinetic energy, but you're also increasing their thermal energy. So those are just something to keep in mind whenever we're talking about thermal energy. Thermal energy is kind of looking at that temperature, and really it's just measuring that kinetic and potential energy. Okay, so temperature is just the average kinetic energy per molecule in a substance. So if I was measuring how much total atoms or how many total molecules something has, and I was looking at are they moving, what kind of kinetic energy they have, temperature is just the average kinetic energy for every molecule in a substance. And how we measure that is just, is it warm or is it cold? So we can read like Fahrenheit or Celsius on a thermometer. This is based on those motion of those molecules and atoms. Again, think about solid, liquid, and gas. Something that is a liquid is going to have a higher temperature than something that's a solid. Think about an ice cube versus water, liquid water. So here are some facts about temperature that we should know. The Celsius scale only goes from 0 to 100. It only really measures the freezing point and boiling point of water. So it goes from 0 to 100. Temperature doesn't mean temperature stops at 100 degrees. It's just on that scale it does. So temperature has no upper limit. You can keep burning and burning and burning things. Things can only burn for so long, but I can theoretically think of an item that just burns super, super hot, and there's no like maximum temperature something theoretically can burn to. But there is a low point on the cold scale, and that's called absolute zero. So absolute zero is your lowest possible temperature. It's the temperature at which all particles have their minimum kinetic energy, which is 0. So basically, things aren't moving anymore. Things are just completely stopped. So if we think about those atoms vibrating in a solid, if we get something so cold that they stop vibrating, that would be absolute 0. Things can't get colder than that. Our next topic then is heat, which we think is a form of temperature. Heat is just thermal energy, and heat goes in a certain direction. So it's going to go from the high temperature to the low temperature. So that's why if you put your hand on a hot stove, you get burnt because your hand is cooler, your stove is hotter. So as you put your hand on your hot stove, the energy is going to move from the hot surface to your hand, which is cooler. So matter doesn't actually contain heat. What it has is thermal energy, and as that thermal energy moves, that's what you're feeling, is that thermal energy. So we talk about that as heat. The colder something gets, the less thermal energy it has, and all heat is just that movement of thermal energy. And remember, it's in that direction. You go from the hot to the cold. When we measure heat, if we're talking about thermal heat, we measure it in joules or calories. And so we think of calories as a food item, but that is actually a measure of you breaking down foods. So it's a measurement of energy. So 1 calorie is actually what's required to raise a temperature 1 gram of water up 1 degree Celsius. So if I have 1 gram of water and I want to heat that up by 1 degree Celsius, so go from 0 degrees Celsius to 1 degree Celsius, however much energy it takes to take that 1 gram of water and heat it up 1 degree Celsius, that's what a calorie is. So we have a conversion going from calories to joules, and we know that 1 calorie is equal to 4.18 joules. So that doesn't make a whole lot of sense right now to you, but we're going to be talking about something called specific heat in class and doing some calculations, and that calculation is going to be important in class. Okay, so specific heat is just a number. That's why it's called specific, and each substance has its own specific heat, which is the quantity of heat per unit of mass required to raise the temperature of that substance by 1 degree Celsius. So think about what I was just saying about taking 1 gram of water and heating it up 1 degree Celsius. If that's water, that specific heat is 1.0. If it's a different substance, say oil or steel or aluminum, it's going to take more energy or less energy to get that to heat it up 1 degree Celsius, and whatever that magic number is its specific heat. So each item has a specific heat that we can calculate. Oops. Okay, so one of our last slides here is this idea of thermodynamics. So the idea about temperature changing, there's 3 laws that go with this idea about thermal energy, and those are called the laws of thermodynamics. The first law states that whenever heat flows in or out of a system, that gain or loss of thermal energy equals the amount of heat transferred. So remember we've talked about the law of conservation of matter? Well, the law of conservation of energy is the same thing, but instead of talking about stuff like materials or atoms, we're talking about energy. So if a system is losing or gaining energy, it's not really losing or gaining, it's just transfer of heat. The second law states that heat never spontaneously flows from a cold object to a hot object. Remember, it always goes from hot to cold. And the third law states that no system can reach absolute zero. So we have that idea that absolute zero can exist. It's when particles stop moving, but in reality, that's never really going to happen. So that's the third law. And our last slide is talking about how heat is transferred. Remember, heat's transferred from hot to cold, and there's 3 ways this can happen. So this can happen through conduction, which is just a transfer of that heat by collision between particles. So think about atoms touching and colliding. If that happens, then that's conduction. Convection is heat transfer through fluids or liquid. And radiation is transfer of energy by electromagnetic waves. So think about conduction as heat transferring between solids. Convection is with a fluid or liquid movement, and radiation is through electromagnetic waves. Okay, so that is your chapter 16 notes over thermal energy and heat transfer. Remember that for every header section we had, there was probably 7 maybe of them. Write a question that will help you study for the test. And at the very bottom, make sure you include a summary, just 3 to 5 sentences over the big topics of these notes. All right, guys, thank you.